the answer. You can use calculator. All right.
All right, I can sense the disturbance in the force on this one. What do we have to use to integrate this? U sub, exactly. U sub. All right, let's take a look at the entire problem. So we know we need the derivative, so f prime of x is 3x squared. And we start our integral as 2 pi integral 0 to 1, and then function itself, which is x cubed, times the square root of 1 plus, and in brackets I have the 3x squared, and then everything squared, and then dx. I can square this one, so 2 pi 0 to 1 of x cubed, and I have the square root of 1 plus 9x to the 4th dx. Remember that the u sub was all about the function derivative pair. You have x to the 4th, whose derivative is x cubed, which is outside, so it's awesome, perfect for our u sub. U equals 1 plus 9x to the 4th, du equals to 36x cubed dx. Are we all agreed on this? Now, I don't have the 36, so I will place a 36 in front and over 36 to fix the coefficient. I need it. So now that becomes pi over 18 integral 36x cubed dx is du. So I have u to 1/2 du inside, because 36x cubed dx is du, and the entire 1 plus 9/4 is u, so square root of u, which is u to the 1/2. Limits. Plug 0 here. This limit is 1, because right, that's 0 plus 1 is 1. And then plug in 1, 9 plus 1 is 10. And now we don't have to go back to x. We can just complete everything in u domain. The integral of u to the 1/2 is u to the 3/2 divided by 3/2. We still have the pi over 18 in front. We're computing from 1 to 10. So these two guys cancel, 2 and 18, you get 9, but 9 times 3 is 27, so pi over 27. And in parentheses, I have 10 to 3/2 minus 1 to 3/2. And there's going to be some number here. Because you can't take square root of 10, so that's not user friendly. Pi over 27. If you want the exact answer, 10 3/2 minus 1. That's the exact answer. And then you can take your iPhone and compute this and then throw it away. So this is how vanilla problem looks like. And those of you working at a tutoring center, next time when the algebra student complains, after a 3-line problem for, something, just show the simplest possible problem in this one, and you have no worries after that. Next example, we're going to go with something spicier. Hopefully it works well. Let's take a look at problem 12. Again, try it on your own. We have time for some time, and then I'll do it on the board. So f of x, which is y, is, I'll write it on the board. X to the 4th over 8 plus 1 divided by 4x squared on 1 to 2.
Which problem is this?
Problem 12 on page 457 in the current textbook. Okay, so y, which is f of x, is equal to x to the 4 over 8 plus 1 over, or minus 1 over, plus 4x, 1 over 4x squared on 1 to 2. Yes. We're in that section still. Oh. I'm green. The cycle does much cycle.
So the radical and the square root, they cancel each other out.
Yes.
All right, then I integrate the 7 inside.
Well, you still have the other one over there, so you will have to do some work there. Some algebra. And where's your dx? And where are your parentheses around? Uh-huh. So the derivative, we have 4 cancels, so x cubed over 2 plus the derivative over here is 1/4 x to the minus 3, so there's a negative 2 and then x to the minus 3. Okay, so what we get? We get f prime of x is equal to x cubed over 2 minus 2x cubed, like this. Okay, that's the derivative. Now we go and we say surface area is 2 pi, we're on 1 to 2, open parenthesis, x to the 4 over 8 plus 1 over 4x squared, and then the square root of 1 plus x cubed over 2 minus 1 over 2x cubed squared dx, which further goes into, now we do the trick for the, so check if the middle one is going to be negative 1/2, which cancels, yeah, well, okay, good. So we can use the trick for this, awesome. We go into 2 pi 0 1, sorry, 1 to 2, we have x to the 4th over 8 plus 1 over 4x squared times, the second one is just going to be x cubed over 2 minus 1 over 2x cubed, using the same trick that we used in the previous one, dx. So now this one will have a plus. Now the only way to integrate this is to actually distribute these, so FOIL, 2 pi 1 to 2 x to the 7 over 16 times x to the 4th x over 16, right? X to the 4 cancels x to the 3, that's x over 16, good. Now 1 over 4 cancels x squared, so plus 1 over 8x, no, x over 8, x over 8, and then the last one is 1 over 8x to the 5. dx. Now we integrate each one of these, 2 pi, open parenthesis, x to the 8 over 8. So x to the 8 over 8, 16 is 8 times 2, 8 times 8, 64 times 2, 128, plus x squared over 2, so 32, plus another x squared over 16, plus, that's a negative 5. If it is a negative 5, it's going to be negative 4, so minus 1 over 32 x to the 4th dx. No, dx, computed from 1 to 2. Yeah. And that's eventually going to work out to be a number. So 8, what do we have? 256 over 128 plus 4 over 32 plus 4 over 16 minus 1 over, so 5, 9, so 256 to 512. Minus, plug in 1 for each, so 1 over 128 minus 1 over 32 plus minus 1 over 16, and then finally plus 1 over 32. So these will cancel. The first one is 256 over 128 is 2. So we have 2 pi. 2 plus these guys cancel by 4, so it's 1 over 8 plus 1 over 4 minus 1 over 5, 12 minus 1 over 20, 128 plus 1 over 16. And that all equals a number because we're lazy.
How's it going? Great?
I tried.
Are you ready? We need some enthusiasm otherwise. Guys, come on, let's go. We have like 1 minute left and another 15 after that.
That was great. That was correct.
10 to 12. I mean, if you guys want to stay. All right, let's take some derivatives because we can. Look at this. 4 x cubed, 4 cancels 8, so x cubed over 2.
You can do that?
I'm taking the derivative.
Explain, you cancel out that the 8 becomes 2.
Yeah, because it's a 4.
Right.
When you take the derivative, this becomes 4x cubed. 4 and 8 cancel. It's bad.
You're absolutely right.
Minus 1 over 2x cubed. 1 over 2x cubed. When you cancel again. So this has minus 2, then minus 1 becomes minus 3, and the minus 2 goes on top, minus 2 and 4 becomes minus 1/2. So that's the derivative. If you are not clear on it, just write it out a few times. Go to Wolfram Alpha, check the steps, do all those kind of things. We have 1, 2. And now, the first parenthesis here is the function f of x, which is x to the 4 over 8, plus 1 over 4x squared. And then we have our square root of 1 plus, and then we take the derivative, which is x cubed over 2 minus 1 over 2x cubed, and then we square it, and then I have a dx at the end. So all we need to do is to integrate this. It's gonna be, we have another one. So now, how you deal with the trick, right? I said that the trick only works, only and exclusively works if the middle term is negative 1/2. If you get anything else, the trick doesn't work. So technically all you need to do is to multiply these two together and then double it. If you get negative 1/2, it's a trick. If you don't get negative half, you're doomed. So, x cubed cancel. 2 times 2 is a 4, so 1 over 4, but you have to double it. So it's 2 over 4, which is 1/2, and it's negative 1/2, which means if it's negative 1/2, when you add 1, it's going to be positive 1/2. So the whole thing will fold and unfold, right? So you can, I'm just going to skip all of those 6 steps in between and just write the solution. So 2 pi integral 1 to 2 x to the 4th over 8 plus 1 over 4x squared, and then times x cubed over 2 plus 1 over 2x cubed, and then dx. So how did I bypass all the calculations and writing this 15,000 times? Because remember, the algebra says that if the middle terms work out to be negative 1/2, negative 1/2 says 1 equals positive 1/2, it's going to be folding it back into itself, right, with the plus. So we have this thing on the bottom. Now we FOIL this, right? You'll get 4 terms, integrate each one of those, and you are done. So, G.
I just did the, I just tried the U for the one on the right in parentheses. It comes out to be, when you right there, it comes out to be the left one. But did you do the U?
You
Say you just use the U as.
over here.
Look, what's down falls, yeah, that one, yeah. If you use that as U, differentiate it, it comes out to be.
This one?
Yeah.
How? Derivative of x cubed
Yeah.
is 3x squared, and you have x to the 4th.
Oh, I was integrating it again. Oh, okay.
Alright. I know. But that's it. This is all exercises, so it's also. We're not going to do that on the test. So, FOIL, we get 2 pi integral 1 to 2, and then now we are going to have x to the 4, x to the 7 over 16, plus x over 16, right, because x to the 4, and then cancel with x to the 3 is x, and then 2 times 8 is 16. Good. Then we have plus 1 times x cubed, cancel with this one, so x on top, over 8, x over 8. And then over here, we have 1, 8x to the 5. At the bottom, there we go, dx. We still haven't integrated. This is just clearing the algebra. Now you can actually, if you take a look in the middle, those two are like terms because they both have a single x, so you can actually add those, so you have less calculations later. So 2 pi integral 1 to 2 x to the 7 over 16. Now I'm adding these two together, so I will multiply this by 2 to get the common denominators. 1 plus 2 is 3, so plus 3 over 16 x, 3x over 16 plus 1 over 8 x to the 5 dx, and these are the 3 terms that I should integrate. However, I haven't done that on a stream, so now you have 2 flavors of it. Integrate each one. Don't forget 2 pi. You have to drag that along. Now we're integrating. So let's integrate. Open parenthesis. It's going to be x to the 8 over 8. So it multiplies into 16. So it's x to the 8. Now 16, that's 8 times 2. 8 times 8, 64 times 2 is 128. Or you use your phone. Plus 3x squared over 32. Minus, because now we are integrating x to the minus 5. X to the minus 5 is going to be x to the minus 4. But then you're going to have that minus 4 in denominator, so it's 1 over 32x to the 4. Computed from 1 to 2. So if you are not comfortable with integrating these things, even though this was from Calc1 6 months ago, for some of you, integral of 1 over 8 x to the 5 dx can be written as 1 over 8 in front of the integral of x to the minus 5. You can do this on the side if you need to. I don't care, just get it right. So that's 1 over 8, and then you have x to the minus 4 over minus 4, clearly negative over, that's the 32, and then x to the positive 4 goes downstairs because it was negative. So that's the last term that I have over there. Now plug in 2 minus plug in 1, you get the number. I don't even know what it is, okay? It's right there. It's a number at the end. And you plug in 2 right next to the 8. And we should get the value. Maybe. It says in the back of the book. You have the text? Yeah, just check it there. Yes.
Can you explain how to test if you can use that sheet again? You said if you cross multiply?
No, you multiply the two terms because it's 2ab. Remember that the expansion was a squared plus 2ab plus b squared?
Yeah.
So that's the 2ab middle term that needs to be negative 1/2. If it's not negative 1/2, it doesn't work. So x cubed and this, so you're multiplying x cubed over 2 times negative 1 over 2x cubed, and then times 2. So here's your 2ab.
Okay.
So 2 kills 2, x cubed kills x cubed, and all left with is negative 1/2.
Gotcha. All right.
So if you are able to cancel it into negative 1/2, that means that the trick works and you can immediately kind of skip through all the algebra in between, right? And just solve it, be done. And you have few of these problems to practice at home. Yes?
In this case, can you like just ignore the 1 over 32 multiplied by 16?
Do what? Ignore?
Ignore the last one, like 1 over 32x is 4, since it's going to be like very small.
Why would you ignore it?
Very small, so
But then it's not exact, and that makes us sad. You all punch this in the calculator anyway, right? And they don't care. So they're like that, right? Because if you're not used to your skills, then you know, calculator skill is to calculate. Make them feel welcomed and special. Give them purpose. All right, so that's the lesson, believe it or not.